Okay, good morning everybody again. Given that I started the recording, I say good morning again. And today we start with exercises. What is the purpose? The purpose is not to tell you something for the exam. The exercises are not a subject for the exam, no questions on these. The purpose is to work together, first of all, in an interactive way. And the second purpose is to learn some more, hopefully, about programming languages. I think this is extremely important today, even if you may feel that you don't have particular needs of writing new programs. There are several commercial programs available for performing several tasks in engineering today. So we may get the feeling that everything is already done in terms of tools for automatic computation, for making calculus, etc. Actually, it happens frequently and more in the profession that we have to make some tasks that are unusual, computations that are unusual. And for this reason, we need, let me say, we need programs that are tailored on the purpose. We need some computer algorithms that are tailored for the purpose. So in this case, we need to set up something in some programming language. I am sure that all of you have experimented the need sometime to use an Excel worksheet in order to make some computations. When you open an Excel worksheet and you make computation, actually you are already programming. You are programming within something that is already half prepared. Because, for instance, in Excel, if you have to compute the square root, you know how to do that. You don't need to write a program to compute the square root. But still, you have to write instructions to Excel in order you have to know what is the name of the function that computes the square root, and you have to write it down. This is already programming. Programming can be done in several different platforms. Excel is an example, but Excel is not very flexible. It is very nice because it's user-friendly, and it's also, as I said, half-prepared. But this half-preparedness, the fact that it's user-friendly, has a price, and the price is a decrease of flexibility, meaning that if you want to make something a bit more complicated, like sizing a structure for structural mechanics in Excel, it's a bit complicated. So you use other programs. Or let me give another example which may be more understandable. If you have to display a sophisticated graph, in Excel it's not really easy. And let me just give you an example. If you want to put the label on the horizontal axis, which are not equally spaced, in Excel you can't do that. So if you want to put the label in 0, 10, 20, 30, 40, this is fine. But if you want to put the labels in Excel at 1, 10, 20, so that they are not equally spaced, this cannot be done. And therefore, you have to use something different. Now, I think it's important that we learn to use several different alternatives, because each platform has some benefits, each platform has some drawbacks. So Excel, the drawback may be the lack of flexibility, maybe also the fact that it's very slow. If you have to perform millions of computations in Excel, it's a nightmare. You have to just let it go overnight. So this is a drawback of Excel. The other platforms have similar drawbacks and other benefits. So it is important that you know several different solutions to your problem. Because if you know several different solutions, of course, I say a trivial thing, you can select the best one. And what is the best one? The best one is the most rigorous, but let me say that in terms of programming, everything that we use is more or less rigorous. But what is a feature of the best solution? It's efficiency. It's the fact that you make your task enough time with respect to others. And this makes you more competitive, makes you attractive in the job market. I'm trying to give you the tools and the information that makes you competitive on the job market, not because you need to defeat other persons, but just because you have to get the max probabilities to find your optimal way during your career. Okay, and this is the reason why I am introducing a new platform. I think you know MATLAB already, most of you know MATLAB. And I make this additional effort to introduce this new platform. Keep in mind that what we are doing, it's not really very detailed. I will not give you a full knowledge of the solutions, of the alternatives that you can use to make automatic computation, and I will not even give you full knowledge of this package that we are now trying to introduce. I mean, I give you just preliminary information. My advice for you is try to autonomously, independently, increase your experience with the use of the PC. I think I already told you that if you want to be very competitive, when you get your degree at the end of your master, you have to feel really confident with your knowledge of the personal computer. You may think that this is difficult. It is not. I tell you, it is absolutely not difficult. It's not a complicated thing. It is much more complicated to learn the models for water resources management or to learn structural mechanics. Definitely much more complicated. It just requires the fact that you decide to do that. And as I said, don't just feel satisfied and happy with what you are required to learn or what you are suggested to learn by me and other professors. Try to make your knowledge of the personal computer, several different solutions, really outstanding. Okay, as I said, it's not difficult. Can I tell you that it's one of the easier way that as a student you may find for becoming outstanding in something, really. Okay, now let me go to this package, and I apologize if some of you already know it, because these first 2 hours will be just an introduction. Maybe that I can say something new for you, but probably you have to be just patient during these 2 hours. Conversely, I will ask the other students who don't already know the software to be patient with me, because I will go very fast, because we need to be very efficient. Otherwise, we can dedicate to this activity like 8 hours. And so we need to be very efficient. As I said, you don't need to follow my advice. You can also decide to drop these lectures because they are not required for passing the exam. This is not, of course, my advice for you, but if you decide to attend and to follow me, I ask the students that don't know this package to be a bit patient and to make an effort, maybe with some homework, in order to keep the pace. Because the pace will be slow during these 2 hours, but then we need to go fast. Okay, now let's go to it, and let me share my screen. This is my website. It doesn't really tell anything useful for now, but yeah, there is something that I may tell you. If you go on the web page of our subject, of our course, you see that there is a part dedicated to the exercises. There is a link, short introduction to R and RStudio, and this is a presentation, a PDF that was prepared by one of my former students, and I think it may be useful. But besides this, let's go directly to what we need. And let me go to google.com, and let's search for R package, just R package. Sorry, this he wants that I get access. Sorry for that. Let me just do this. Okay, good. R package. Now I succeeded. The first link is the R project for statistical computing. Click on that. Don't be concerned about the word statistical. It's not a package for statistics. It was created for that purpose, but now it's a computing platform. It's a computing suite. Okay, here you get to the main page. We need to download the installer, and you go to CRAN here. Select a cloud. It's really not important which one you select. And then you have the 3 downloads. I suppose that you are using Windows, or you can use Mac. You may use Mac. I assume that nobody among you is using Linux, but if there is a Linux user, besides getting my congratulations, then just let me know so I give you specific instruction. Most of you will, I guess, would use Windows. Here we get to, sorry, you need many clicks. To the download page, you have to click and download the base. And here, finally, you get to the link, download R for Windows, and then we can download it. Do I need to go back?
No.
It's okay? Okay, download. I can download it. I saved it, actually. And then, once that you downloaded it, you just have to double-click. If I try to do that, probably I get a no from this PC. I try. Let's see. Otherwise, it looks like it allows me to install it. Just click on OK, OK, OK. Don't get any option. Thank you. And let's see if I succeed. I still, yeah, it seems that I am allowed. And then we have to wait a little bit that the installation is completed. It doesn't take a long time. And while it's installing, if you are just waiting, there is another thing that I wanted to tell you to download. Manuals. Here, you click here, manuals. And then there is the first one, an introduction to R. Just download it. I think it is useful, okay? And you see, save it on your PC. This is a nice introduction. We don't need it, but keep it there because when working at home or whatever, if you need any information, this is excellent. It's really excellent, okay? Now, let me check if, okay, it looks like it's fine. We are done, okay? If you look in your Windows menu, you see now R, but don't click on it, just wait, okay? Or if you click, it doesn't explode, it doesn't happen anything, but just wait because we are not done with the installation. Now, let's go back to Google. Perfect. And now let's look for this, R-Studio. RStudio, open source and professional software for data analysis. Good. Let's click on it. If you get behind, just let me know, even remotely, please. If you have any problem remotely to follow, or if you need some waitings, let me know. RStudio. Okay, let's see, download. Download, choose your version, free, of course, not buy, okay? Download. Download RStudio for Windows. Download. Same thing as before. Now we get to the download page and double click. Okay, in this case, it doesn't allow me to install it. In fact, this is what I remembered. But you are allowed on your PC. I suggest that you install it. I don't understand why I am allowed to install some programs and not some others, but we have a problem, okay? I can't solve it myself, but I found a workaround, no problem. So I'm just waiting for you to install it. Once you are done, you can close the web page. We don't need any download, any installation anymore. And in the Windows menu, you will be able to find RStudio. And then you can finally start it. I can't show you how it looks like for now because I didn't install RStudio. But now I shift on my PC to which I'm connected remotely. Once you started RStudio, this is what you should get. Something similar, okay? You may get on the left 2 windows instead of only 1. Okay, now I am waiting for you to get to this stage, more or less this stage. I said that you may find another window. Let me just see how I can get the window with that you probably will find. Just 1 second. Sorry. Okay, you may find something like this. But it doesn't matter. If you have a different visual, it's not a problem. What is important is that you get this window with written all these writings, our version, blah, blah, blah. Your version will be probably different from mine. Don't worry for this. And this window is called console. So you should get this console that you see on the left, bottom left, you should get it, okay? This is the console. Now I close the other window. This is a suite. RStudio is a suite. I changed the position of the camera because if you, for students who are attending remotely, I think that you now cannot see the screen, and you don't really need to see it, but still, I prefer to change the position of the camera. Yes, just 1 second. Very short cables. Very short. Okay, let's see how we can do this. Oh, yeah, thank you. But I'm not sure if I can. Okay, this is for racing. Let's see if there is a way to. I don't think so. Let's try to do this. Still very. Okay, students, I hope that you can see at least something remotely. Yeah, you can see almost everything. Let's hope that it works. Okay, now, of course, remotely, if you want to see the screen, you should pin the video so you get the video on the full screen. Any questions so far? Is there somebody behind? Okay, very good. As I said, this is a working suite, sorry, not a suit, a suite. And there are several different windows that you can, in a way, displace on this screen. You see 3 now, and they can be closed, can be reopened. It's not a problem. The important thing, as I said, is that we have the console on the right, and I expand it a little bit because I don't need the other windows now. You see that you can resize the windows, etc. The console, first of all, let's clean it because I don't like all of these writings. Let's just type Ctrl+L at the same time. Okay, you see that there is a sign on the left, a major sign, which is followed by a cursor. I don't know if the English word is correct. That is lighting, it's blinking, okay? It means that the PC is waiting for your input, is waiting to know what to do. And of course, it speaks a language, and we have to know the language, because if we want to speak with the PC, we need to know the language. There are several programming languages. R is using its own programming language, which is very similar to MATLAB, but it's not the same. And you may say, why this need of using different languages? Okay, think about countries. Why do we use different languages? Because we had a different origin. The same for programs. They were originated in different environments during a time when communication was not so easy. So when communication is very easy, it's easy to learn a common language. 30 years ago, when this program started, it was not so easy to communicate. There was no internet, no web, etc. So they are slightly different, okay? But there is one thing that you have to take into account. Once that you got the concept of how algorithms work, okay, once that you got the logic behind it, the logic is the same. It's like to speak, okay? There is, in communication, humans have a logic that follow, and any language more or less follow the same logic. By using this logic, we can understand each other, even if we don't speak the same language, more or less, okay? The same for the algorithms. They use the same logic, and therefore, the logics, the basic concepts of programming are really few, really few. You just have to put in your mind and understand these basic concepts that form the logic. Basically, these concepts allow the machine to know what to do and to make choices. The machine is not intelligent, cannot decide what to do, and therefore we need to drive the machine when it needs to take decisions. Good. So the machine is waiting now to know what to do. And for instance, we may make a simple thing. We may write 2 + 2, 4. Okay? Very simple example. So you can make computations with this platform, and you can make multiplications, whatever, and you can make many of them, like 2 + 2, 3 × 2. Okay, it gives priority to multiplication. Just keep in mind that the priorities more or less are the same for all the languages. And if you want to raise a power, you can make 2 to the power of 3, which is 8. Okay, very good. And if you make a mistake like 2 to the power of minus 2, no, okay, this is not a mistake actually, sorry. It's okay, let's see. Anyway, let's make another mistake. We will make many mistakes. So an example of mistake will be late. Sorry?
1 divided by 0.
2 divided by 0. Okay, this is infinity, and it's not really a mistake. Okay, but we will find many mistakes, don't worry. I just want to make a premise before moving forward. What I said, we have to learn the language, okay? Okay, yeah, we will make many other, no problem. In any case, if you make a mistake, the program tells you, but be always careful when you dialogue with the program, when you dialogue with the PC. In some cases, like 2 divided by 0, it is a good example actually. In some cases, what for you it's a mistake, for the PC is not a mistake. And you have to be a little bit careful because, I mean, you don't have to assume that if you make something wrong, the machine tells you. This is the basic concept. And if you make a mistake, you are responsible for it, not the machine. Okay, so this is why I say you have to be careful. But let me make another premise, which is more general. Now we are learning a language to speak with this platform, with R. Perfect. But actually, there is a more primitive language behind it, which is a language that allows me or the programs like R to talk to the machine. And this is, the machine just doesn't speak a language. As you know, it's just composed by a series of bits, which are lamps that can take only 2 positions, on and off, okay? Light, no light, that's it. And there are millions of them. And by combining this on-off, the machine works. Because the machine speaks a very primitive language, okay? So we need, first of all, something that allows us to interact with this very primitive language. And this is the operating system. It's Windows or Mac or something else. This is something that stays behind any application. It's a primitive interaction, a primitive form of interaction that stays behind R, behind MATLAB, behind whatever. What you do when you turn the PC on, the first thing that the PC does is to start Windows or what is called the operating system. Usually, we take the operating system for granted. We take Windows as something that is part of the PC. It's not like that. We may have different choices for using operating systems. We may have different options, different operating systems. An example that you know is Mac. Those of you who use Mac, they don't use Windows. And we know that Mac has some advantages with respect to Windows, okay? And what are the advantages? First of all, viruses. Mac is more immune with respect to Windows. It's more efficient. So if you use an old machine, a machine that you bought 10 years ago, a Mac, you can still use it. A Windows machine, yeah, you can still turn it on, but it's very, very slow. There are some differences. There is a third option that is very popular, which is Linux. Probably you don't know this term. This operating system can run on any PC. It can be a Mac, it can be an Apple, it can be whatever. And it's completely free and open source. Actually, it was an operating system that was created for running on big machines to manage very huge masses of calculus. So it was conceived just to be very efficient in managing massive computations. This is not the logic of Windows. Windows is conceived to be user-friendly and to provide user-friendly interaction. With Windows, we use menus, we use, just with the mouse, we can do almost everything. So this is the logic of Windows. The logic of Windows is to make the PC usable by everybody in order to reach the whole population. There is another logic behind Windows, which is making money. But okay, this is fine because, I mean, it's fine that people that work for something are paid. Okay. Linux, or let's call it Linux, at the beginning was called Unix. Linux, Unix, they were created with a different logic, to manage massive computations for expert people. And therefore, the interaction was not user-friendly at all. It was difficult because useless things like making something understandable to everybody were dropped for the sake of efficiency. The logic was to be very efficient in making computations. It was other times, and we didn't have so much computing power. So it was conceived, again, to be a system for experts, so no useless things, and therefore no mouse, because the mouse, if you think of it, it's useless. I mean, it makes you comfortable, but it's not needed. And they worked with the keyboard, just with the keyboard and giving instruction. This explains why now you see a blinking light waiting for a keyboard input. Okay, I cannot give an input to this console with the mouse. With the mouse, I can use the menus there, but it is waiting for a keyboard input. And this is the logic behind, because at the beginning, they didn't want mouses because for the mouse, you need an interpreter, etc. It takes efficiency. They just wanted to be very efficient. Perfect. And this was then usable by an elite of people. But it was attractive, even for students. When I started my studies, my degree, we had very, very primitive PCs, and we were attracted by Linux, by Unix, because it was indeed giving more power. Okay, and then the evolution came of the machines, and keep in mind at the beginning, Unix was not, Linux were not conceived for working on a personal computer. They worked on big machines. And then the evolution came and the personal computers came. And then they devised Linux, which is an operating system derived by Unix working on personal computers. And now it's an alternative. It's a good alternative to Windows, but still it requires some skill because it is much more powerful and more flexible with respect to Windows. You can do with Linux things that you can't do with Windows if you are, let's say, a good user. On the other hand, the user friendliness suffers a little bit. Still, about 14 years ago, I decided to give up with Windows, and now I'm working with Linux. So what you see on the screen is RStudio running under Linux. And the reason why I chose it was that it made me more competitive. Now I can select which one to use. So on my PCs, usually I have Windows and Linux, and then depending on what I have to do, I choose one or another. For instance, during the pandemics, I used Windows a lot because connectivity in terms of Zoom, efficiency of Zoom, Teams, etc., is a bit better in Windows. Because for Linux, it's not a priority. But on the other hand, when I have to make computations, when I have to, in a way, to be creative, much better to go with Linux. I just make this introduction because I want you to know that we are not obliged to follow a preconceived solution. Conversely, if we want to be creative, and creativity, as you know, because I made a premise, it's one of the 21st century skills. If you want to be creative, you have to know different solutions. So what is my suggestion for you? If you are a Windows user and if you have an old machine, just download Linux. What I suggest is Ubuntu. Just look on Google for Ubuntu and put it on the old machine and just see what's like. It's not difficult. And if you learn it directly from it, you would find it extremely easy, like you found easy Windows. There is no difference. And then, of course, if you want to be creative, it becomes a little bit more demanding. But on the other hand, Windows doesn't allow you to be creative. And finally, Linux is open source. It's completely open. It gives you a lot of more opportunities because every program is free. So if you are a Windows user, you know that some programs are free, others have a 30 days license, others you cannot use them for free. Absolutely, you have to pay. You know, the fact that the Linux is free means that you have several more alternatives. You can become part of a community of people who create programs. When you go to the job market, I tell you, if you say, I can use whatever, Windows, Mac, Linux, it makes you more competitive. Mac is derived by Linux. So Steve Jobs had this great intuition. He took the Unix operating system and made it user-friendly. And he anticipated what the open source community did later. So, and in doing that, he made it commercial because, of course, he also wanted to make money from his work. But they are very similar. They have the same safety against viruses. By the way, when I passed from Windows to Linux, my first motivation was viruses. I was really fed up. And in Linux, you don't need any antivirus, any protection. Or let's say it has its protections, but very weak. And they don't take computing resources from the machine. Okay, I think we can move forward. Just keep in mind that if you look at my screen, you see something different. You see also the look is a bit different. It's also less exciting than Windows because Linux is not looking at exciting things. It's just looking to efficiency and safety. Okay. Now, with the software, we can make computations, we can make a lot of things. But now let's introduce, and let me clear the screen, the functions. Because like in Excel, you have a function, you have a name of something that makes the square root. Even here, we have names. And so let's take the square root. The name is sqrt, and the argument is to be put between parentheses. This is a very good example of a function. It's, in a way, an aid that you have. If you want to compute the square root, you don't need to type 4 to the power of 0.5. You have a function, sqrt of 4 or 16. And you may say, I don't need it. In this case, yes, you don't need it because, I mean, it's faster to type 4 to the power of 0.5 than typing sqrt of 16. But, for instance, if you take the logarithm of something, well, it's instead of thinking on how to compute the logarithm without a function, let's use the function. By the way, log 10 is logarithm in base 10. Or, let me give you another example, log 10, comma 10. What did I do here? Between parentheses, I put two arguments separated by a comma, because I know that the logarithm function takes several arguments, and the first is the number I have to compute the logarithm on. And the second argument is the base of the logarithm. Oh, this opens a kind of can of worms, because you may think, yeah, but how can I know the name of a function, and how can I know what are the arguments of a function? Because if you didn't know that the logarithm takes two arguments, then it's a problem. You wouldn't, how can you learn it? Okay, three solutions. The first solution is to look at the introductory guide that you downloaded on your PC. I don't recommend this solution. The second solution is if you know the name of the function. Let's suppose that you knew the name of the function log logarithm. You knew the name log, but you didn't know the arguments. You didn't know how to use it. Okay, second very easy solution. Let me clear the screen. Question mark, log. No, log. Okay, and you see on the right what happened. Let me expand this window here. Logarithm, and let me do this. Logarithms and exponential. Description, log computes logarithms. Logarithms, by default, natural logarithms. By default, natural logarithms. Log 10 computes common base 10 logarithms, and log 2 computes binary base 2 logarithms. The general form log parentheses x comma base computes logarithms with base. Fine. We knew what we needed. Okay. There is some more here. I would say that let's just, in this some more, focus on what you see here, which I am selecting. Let me just do one thing. Let me see if I can increase the font size. Just 1 second. I think it is under view. Yeah, zoom in. Let's see. Okay, very good. Control plus. Very good. So I selected logarithm x comma base equal exp1. What is exp1? It's e. Okay, it's basically this instruction says that we compute the logarithm with the natural logarithm with base e. But look, the second argument is given a default. Okay, so when we are under usage, you learn how to write a function and what are the arguments. Okay, and you learn from here that the second argument, the base, is given a default, which is exp1. It means that when you type the logarithm, I go on the console, log 10, I don't need to give the second argument. By the way, you see that RStudio gives also to me in yellow the usage, which is useful. I don't need to give here the second argument. Why I don't? Because there is, for the second argument, a default. Okay, let's suppose for the first argument there is no default because it's the number to which I have to compute the logarithm on, so it can't be given a default. Let's suppose that we make a mistake and we give only the second argument. How to do that? Base equal exp1. Error, argument x is missing with no default. Okay, is it clear? Now you learned something important, like there are functions embedded in R, like they are in MATLAB, and you learned how to get help. But there is a third solution, I said, for getting help. Let's suppose that you don't know the name of the function, so you can't type log. Okay, let's give an example, like, I don't know, I want to compute the cosine function, and I don't know how to write it, okay? Maybe it's cos, but I don't know. I cannot search with the question mark because I don't know the name. Okay, so third solution, very recommendable. Do I have? No. Open a browser. Go to Google, and then you write R project with the dash, and then cosine or cosine. I don't know how the pronunciation is. Probably it's different, but I think we understood each other. Okay, good. This is not a good example because there is a package called, there is a synonym. So let's say, let me go back. R project trigonometric function. Trigonometric functions, okay. Usually you have to go just on the first link. Very good. It's cos, okay, and there are several of them, but we are interested in the cos. So let's try it. I go in R and I question mark cos. Sorry, because I didn't write. Okay, trigonometric function. Usage, cos x. Okay, let's try cos pi -1. Very good. Pi is the name that R uses for pi. Okay, cos pi half 0. It's not 0, but you see e to the power of -17, 0. Okay. Okay, cos 2 pi pi 1. Good. So go to Google and you get help for R. This is the essence of what I wanted to say. Okay, now let's move forward. I try to expand the console. Let me see if I can. Okay, very good. Let me clear the console and let's move a step forward. This is easier. A equal to defining a variable. Very good. A times 3, 6. Fine. B equal 10. A times B. Okay, nice. I put variables into the memory. How can I know what variables I stored? ls, it's a function with no arguments, A and B. There is a second way of getting the variables, which is here. You go to the window environment. Nice. You see AB 210. Let's explore here. The other window, history. Oh, nice. It keeps memory of what I did, all what I did. Nice, very nice. And also another nice feature. Let's go to the console and type on arrow up. It gets the previous instruction, 2 times arrow up, then the last but 1, and so forth, up to the beginning. This was 2 plus 2, that was my first instruction. This is nice, and use it, please, because if you want, write again the list, and you write ls parentheses. It took like 2 seconds. If I just go like this, it's 1 second. And you may say, okay, 1 second is nothing. At the end of the day, the sum of many 1 seconds is maybe 1 hour. And, 1 hour free at the end of the day is not so bad. You can rest, or you can go out, take some jogging, whatever, take a beer. It's not so bad. And no, this is a kind of a joke, but it is a serious concept. When you work, competitiveness comes also from efficiency. If you are asked to perform a task and you take half time with respect to a competitor, you are okay, and people will go back, will come back to you. And efficiency, it doesn't mean if you are quick, it doesn't mean that you are not rigorous. There is a say in Italian which says basically that quick and well done cannot stay together. Presto bene non stanno insieme. Actually, this is not true. Quick and well done can stay together. And in a very efficient person, they fit well together. And sometimes if a person is not efficient, is also not really rigorous, because so just learn what is the purpose of knowing several different solutions to a problem, to be efficient. So even when using a package and you learn that arrow up allows you to get the previous instruction, use it, because it looks like it's nothing, but it's not true that it's nothing at the end of the day. Because these days, with automatic computation, we do a lot of things. It's not like in the past. We do really a lot of things. Okay. Good. Now, another step forward, vectors. Variables are fine, but we also need vectors. How to define vectors? Okay, let's write D. I say D, but you can just write something like my vector. Name of variables, it's your choice. To be efficient, I suggest that you don't use long name for variables. On the other hand, you have to remember the names. So it may be useful sometimes to use a long name for a variable if it helps you to get oriented in what you did. Okay, it's just a compromise, very subjective. One recommendation is when you deal with the algorithms, you have to take a note of what you do, because algorithms, they have the nice feature that you can perform several tasks. You see, even now, how many things I did. But the problem is that given that they are many, even after a couple of days, you don't remember anything of the meaning of what you did. You don't remember names of variables, what is A, what is B, you don't remember anything. So please beware of that, because it is a classic. We make algorithms, and after 1 week, we cannot use them anymore, and we have to start again from scratch because we don't understand what we did. So you will make exercises in R. Just take notes. How to take notes? Let me cancel my vector. Comments. This is a comment. This is a comment. In your history, we can write this. Now we introduce vectors. And you see that it's in your history here. So when you look at the history, you get the comment. If you write an algorithm, put comments, explain everything that you did. You know that now in scientific research, we are we are invited and to some extent obliged to make everything available open source, data, software, and the software we are required to make comments. The software must be understandable. And what we do in research must be reproducible. It means that you give the software to another person, and the other person, by using your data, can reproduce it. This is a very nice thing, a very nice evolution. Keep in mind that up to, I would say, 5 years ago, I was told by my previous advisor, don't give your software, don't give your data, because this must be kept secret, because it's our knowledge and we cannot share it because we paid for them, we paid for the software, etc. And I understood the motivations, but I have to say that the fact that very recently we came to the conclusion that everything that a researcher does must be reproducible, this is great, really great. Okay, now we introduce vectors. So my vector equal, I need a function to define a vector. This function is simply called C. And let me open the parentheses and let's put the elements of the vector in sequence. Okay, so if I write my vector, I get it back. Important thing, let me write again my vector, okay? My vector, okay, took some 3-4 seconds. Second solution, my tab, 1 second. With the tab, you complete the name of the function, the name of the variable, whatever. So you can use even a long variable name. If you just remember the first two, it's fine. In this case, only the first one probably would be okay. No, it's not okay because I put the tab and RStudio tells to me, you have these functions that you can select from many. So no good. Let me put my vector. Okay, and if I want to get a single element, my vector, square parentheses 1, oops, sorry, I made a mistake. Square parentheses, I don't understand, let's just do like this, 1. My keyboard was a bit strange here, but I don't think you have the same problem. Yeah, no problem. Or my vector 2, etc. So I can write my vector 2 times 2, 6. I can also write my vector times 2. What are we going to get? Each element of the vector is multiplied by 2. Very good. Now we are dealing with, we know how to deal with variable vectors, functions. We are almost done. Meaning that with a minimal effort, now we can do here everything that we can do with Excel, with a minimal effort. But I am sure that at this stage you would say, I prefer Excel because I see what I get. Everything is there. Actually, even here, if you look at the environment, I would say that even here you can see everything. But I agree, I would agree that Excel is clearer in a way. And of course, we would prefer Excel at this stage because we still don't know what R is offering more with respect to Excel. But we will learn quite quickly. Now, an important thing, we didn't save anything, so if the computer crashes now, we don't get anything back. And another thing, I cannot undo in R. So if I remove my vector, and in order to delete it, the function is rm, stays for remove, and then here I can write my vector, and I say, no, I made a mistake, I can't get it back. On the other hand, I have the history, so I can go back and to the definition and recreate it. So with respect to Excel, R has the history, which is useful, but doesn't have undo. The two things are equivalent. I mean, the history can replace undo. If I wanted to repeat everything I have done so far today, there is a command that allows you to repeat the history in 1 second. So, I mean, I wouldn't be concerned if I removed something, I deleted something that I shouldn't. I would be concerned if I get a crash, because with a crash, I don't save neither the history nor the data. Okay, so how to save? there is one quick way of saving, which is quitting. If I quit with the function Q, I should be, you see, I am asked save workspace image. Okay, let's cancel, because I don't want to quit. But if you quit and you press yes here, when you start back RStudio, you find precisely the same environment, same data, same vectors, same history, whatever. Okay, but what if I just want to save? Okay, there is, I don't remember the name of the function, so let's put save here. And then you see there is RStudio telling me that I have some options to decide with. Let's go to save history. Save history, saved. But it only saves the history. Save image. Save image writes an external representation of the R objects. Or save image is just because I can use save image, etc. Save image, read in the yellow, is just a shortcut for save my current workspace. Okay, good. If I save the workspace, I saved everything. Still, I think if I quit, yeah, it asks me if I want to save, but actually I already saved. Okay, now we learned how to save. Any questions so far? Okay. Now, let's move forward, and I think the best way to move forward is to get an exercise. So let me just go on my website and let's look at the first exercise. I don't remember what kind of exercise is. Let's check. Okay, there is an exercise, estimation of the flow duration curve. Let me open it. And basically, if you click on, let me do it again. If you click on the first exercise, estimation of the flow duration curve, you should get a download of a zip file. And if you open the zip file, of course, I am a Linux user, so you get a different window, etc. Okay, and you may also get a different option. I'm not sure whether it opens in the browser or whatever. But if you download the zip file and you open it, you get to this content, which is the text of the exercise in PDF and a text file. Could you, anybody has problems to get it? Okay, can I know, at least in the room, do you know what is a text file? Raise your hand if you know what is. Not everybody. Okay. A text file is a file that is readable, is written in a universal format. I am simplifying things, okay? So it is a universal format that can be read by Excel, by R, by whatever package. It is with no formatting, of course. There are only numbers and letters there. And the format is universal. So the reason why I gave the data for this exercise, the exercise, let's forget about it for now. We will see it next time. But just have clear that there is something to be done by using data. And the data are given in the text file. So you see that the name is Po Ponte Lago Scuro. Actually, these are river flows of the Po River. It's a long data set it's about, it's daily for 90 years, so it's about 30,000 data. It is something quite long. Now, I just want to to perform this task with you. Uploading this text file, this data, into R. Okay. You would have to make a similar thing in Excel. 30,000 data, you cannot type them one by one. You should upload them into Excel or into R, whatever. In Excel, it's quite easy because you can open text files directly. Even in R, it's easy, but you have to know the instruction. Okay, first of all, let's double click on it and see what's there. Okay, if you double click in Windows, you should open it with Block on Note and Notepad. In Linux, it is opened with a text editor, which is similar to Notepad. You see there are only numbers. These are daily river flow data, only numbers. Okay, let's close it. I just wanted to make sure that what is the content. When you upload something into a package, just have a look at what is the content, because it may be that it's a virus. I just wanted to open it, and I opened it with no concern, first of all, because it's downloaded from my website, and also because I am a Linux user, so I am not afraid by clicking on links or whatever in Linux. Okay, now, to upload it into R, we need to extract it. We need to extract it. So let's extract the file. So again, I am a Linux user, but I think in Windows, if you right-click on the file, you get a menu with extract. And probably you are asked the position where, let me see if I am asked. No, yes, I am asked the position. I put it in my desktop. So if you can extract the file and put it in the desktop, I assume that you know how to extract files, but if not, you see, you just double click on the zip and then right click on the file, pop on Telago Scuro like I did here, and then you get a window, and then you get extract. Okay, and I put it in my desktop. Do the same, put it in your desktop, and that's it. Okay, now let's go back into RStudio. We may have two options in order to upload a data file. Let me tell you the first one, which is the more complicated, directly from the console. Okay, let me just decide that the name of the vector in which I put the data is PORIVER. PORIVER equal to, the function is scan. Okay, good. Now I have to put the file name between commas in the has argument. It is the only argument that I need. You see a long list of arguments in yellow, in the yellow rectangle. We can ignore it. We can ignore them. But if you are interested in knowing the meaning of the arguments, you just have to put $scan and read. Or you go to Google and you put our project scan function and read the instructions. Actually, we don't need any more, as I said, argument besides the name of the file. Why? Because the file just contains the numbers. I don't have to say skip one line or whatever. The problem, but still there is a problem, because I told you it's not easy. The problem is the path of the file. So the file name needs the path. And let me give you an example of what I do in Linux, but don't do anything. Wait for me to complete it, because I know the path. It's, let me just see, home, perfect. Desktop. And then there is the file name, PO. Okay, you see, read 32,850 items. I succeeded. Now, the question is, what is the path of your desktop? Because you know the name of the file, but not the path of your desktop. Okay, let's try to find it. You have two options. Either try as I did. So let's write. You may try this. Forever equal and commas C double slash Windows, and then see if it gives you suggestions. If not, maybe Windows is capital letter, I don't know. I don't get any suggestion because this path doesn't exist in my PC. So you can find the path by trial and error, first thing, of the desktop. Second solution, this one, it's not very recommendable, this one that I just gave. Second solution, copy the file from the desktop, put it under Documents, and then you just need the file name, okay? I say again, now the file po.pontelagoscuro.txt is in the desktop. Move it into Documents, or Documenti for the Italians. And then you should be able to find it by just writing PO and the tab. I get no matches, but you should be able to get it. This is the second solution. Did somebody of you succeed so far? Not yet. Third solution, use RStudio. But beware, learn from the console how to do things from the console. So learn this issue of the path of the file, okay? Because this is an issue that it's complicated for Windows users. For a Linux user, it's very easy. You see that I know my path very in a unique way. In your case, with Windows, it's a bit complicated because sometimes the path of the desktop is complicated. I don't understand why Windows has this complication. That if you have to find the files stored in the desktop in a way that is different from just looking at the desktop on the screen, it's a problem. Okay, but let's try to use RStudio. This is by far probably the easiest way, and I don't really remember how to do because I prefer to use the console. But let's see. So file, import dataset from text. Good. Oh, perfect. Now I have a nice window. I click on the desktop. And then I get my file. Where is po.pontelagoscuro? Just 1 second. It's let's see. Here it is. Open. You see that there is a preview. And then you can go down and say import. Very good. Given that I'm not sure if the file was imported correctly in this way, first of all, it gave a name. The name is po.pontelagoscuro. Okay, let me see. io dat, Ponte Lagoscuro. Let me try to see the first number. I want to make sure that, yeah, it was imported like a table, not like a vector. Let me just check. I think I didn't specify that it was a vector when I imported. So let me just remove it and import it again. Oh, sorry.
The first column of the table.
Sorry?
Maybe it calls the first column of the table.
Okay, I understand. Let me just see. Let me just try to import again. Okay, let's see. Name, first of all, let me put this por river. Very good. And then let me see, heading, no. Okay, row names, automatic separator. Put file. Data frame. Okay, let me check. No, I think I have to import it in this way and then do like you suggested, because I don't think that there is nothing. Okay, import. And then, as you said, this is a table, so let me see. Okay, so I think that we may do like this. Just let me try and then okay. Yeah, okay, I succeeded. Okay, but what I did is a bit sophisticated. So it was imported like a matrix, okay? And then what I did, I first checked with this instruction that it was a matrix or not, if it was a matrix or not. And the function dim gives the dimension of something. And the dimension, in this case, was resulted 32,000 plus something and 1, which means that it's indeed a matrix with one column, and in the column there are 32,000 rows. And then the next instruction was to overwrite the matrix with the same matrix, but only the first column. So I overwrote it, and then what I finally got is a vector. In fact, if I now repeat dim for river, sorry, it's null. It's there is no dimension because it's a vector. But if I use the function length for river, it gives to me 32,000, because to get the length of a vector, you need to use the function length. To get, if the object is a matrix, you can get the size of the matrix, the dimension, with dim, D-I-M. So I imported this fantastic data set. Okay, I'm not sure if you could get what I did. I suggest you that you make some homework, and you have everything you need to make your homework. And I suggest you also to learn with the scan function, because for the same reason, you need many different. You need to know many different alternatives. Now, what did I do? I imported the data set. By the way, it's quite an important data set because it's daily flows of the Po River. It's a very long time series, 90 years. By the way, this stops in 2009. I have another one up to the end of 2021, which is indeed 101 years. It is a very important data set. And when you import a data set, of course, you are importing because you need to work on it. You need to make computations. And the first thing that you have to do is to check if the data set is reliable. So the very first thing that I did is to check that it's into a vector, which is fine. I succeeded in getting it into a vector. But then the question is, these numbers are reliable? Because I may have made a mistake in importing the numbers, or I might have got data that are not reliable from the beginning, from the provider. So I need to check. And how can a data set be checked very quickly? First of all, I suggest to check the orders of magnitude. And then, second thing, make a plot. Because the plot is really very powerful. You get a visual of what you're working on. It is something that you have always to do. Actually, the data set, the plot also allows you to get the orders of magnitude. So you may also suffice, you may also be happy with the plot only. But just to give you the information, let's look at the instructions that allow you to see the orders of magnitude. So let me just first say, I know that the Po River, from my experience, the average flow should be something around 1,1500, because I forgot to say, these numbers are flows in cubic meters per second. Okay, let's compute the average, mean Po River. Perfect. This is the number I was expecting. I know that the minimum number should be, for sure, greater than 0. The Po River is not intermittent. Should be something around 500. So let me just, instead of the mean, let me put here mean. Okay, it's a bit low, but okay, that's fine. And the max should be something like 11,000. Oh, it's a little bit less, but that's fine. I think it is, overall it is reliable. I mean, the orders of magnitude are okay. Now let the plot, very easy, plot Po River. Okay, let's try just to put plot of Po River and see what happens. Okay, figure margins, okay, because the plot window is too small. Let's do it again. Okay, this is not really nice because it's dots. Not really nice. I can't see everything. I want a line plot. How to do that? Plot Po River, comma. There is a second argument, which is type equal line. Okay, much better. Let me expand it a little bit. Much better. I think with this plot is, I am happy with it. You may not like black plots. Okay. Col equal red. Okay, a little bit better, more light. The plot that you see here, let me make two comments. First, I think I was quicker than in Excel. I mean, I was slower in importing the data, but in making the plot, changing the color, I think I was a bit quicker. First comment. Second comment, it doesn't look really nice, okay? Because, for instance, if you look at the vertical axis, it's not nice that the labels are up to 8,000 and then I'm missing a label up there. And also maybe that I would like a grid, to see a grid. And also I don't like that here I have a thick mark, but I don't have the label there. It's not really nice. Just let me anticipate that there are instructions for making it nicer and nicer. And I give you just a couple of examples. Do you want the grid? Okay, grid. Here is the grid. And do you want to put labels in the right position? Okay, let's do like this. Let's remake the plot, and then let me just clear the screen. And then for the vertical axis, let's say, first of all, let's put a label. I don't like pour river, so daily river flow. And let's forget about the units. I should put the units there, but it's not easy because I need an exponent, because cubic meters divided by second, I need an exponent. It's not really easy. And let's put now the labels. So let's add another argument. And I think it is y limit equal e 0, 0, 10,000. Okay, it's a bit better. Still, I don't have the labels where I would like them there, but that's fine. There is a micro open. Do you have any question remotely? No? Okay.
Sorry.
Yeah?
Regarding to the function scan,
So, yeah.
does it only work if the file is saved in documents, or also if the file is saved in another folder? Sorry, desktop, not documents.
No, it should work everywhere. But if you put it in documents, then you can omit the path. If it is in the desktop or somewhere else, you need to indicate the path, which is not easy in Windows. Because in Windows, I can tell you, if you want to find the path of the desktop in Windows, I can give you some this suggestion. You open, let me go in Windows. You open the file manager and Windows accessories, just 1 second, it's Windows system, file explorer. Okay, where is it? Just 1 second, because I think, oh, okay, here it is. And then you see the desktop. If you go over the desktop and you right click here, properties, you get somewhere the path. Let me see, you see here, path, see users Alberto Montanari. This is what you should put in R between commas and then the file name later on. But when you put the path into R, you have to substitute the slash with a double slash. Don't ask me why, okay? Sorry?
Only at the beginning?
All of them. The slash is to be substituted with a double slash. Okay, don't ask me why. So, and this can be done in any position. So if you have like download and you want to get the path of download, properties, and you see, no, this is still the desktop. No, sorry, for the desktop, the path was actually, let me just go again in the desktop. I think C users Alberto Montanari should be followed by desktop. I think C users Alberto Montanari, let me see. Let me click on the desktop. I don't have anything on the desktop, but let me see Teams. Okay, now let me see. Now you have, no. You have to double click on the, you have to right click and get the property of the text file that you want to import in R, okay? Which I don't have here in the desktop, but I could put it there, but okay, I think it is clear. And if you don't succeed next time, we can do it together. Any other question? Yeah, please.
Sorry, when we want to plot this graph in the Excel, it does match the test, the end of the first line to test of the second line. I want to know that is it such a line bar or bar chart? Each column is different about the picture. I mean.
You mean about the picture
Yes.
here?
The all of the line is matched together, or there are such as a bar line in bar chart in the Excel?
No, it's a line matching the points. And let me just give you this example. If instead of plotting everything, I plot per river only the first 10 numbers, and it is 1 and semicolon. Is it correct, semicolon, for due punti in Italian? I don't know, but I think, just 1 second. Okay, here is 1 second. So this answers your question. You see that it's a line connecting the points, and this is a graph with line and points. I think this answers your question. Is it correct? Okay. And just have a look at what I did. I changed the type to both. It's line and points, or I could put the P only points. Other questions? Okay, if you missed something, next time when we start on Monday, just ask me, okay? Because I was a little bit, at the beginning slow, but then I went fast. Okay, any question remotely? Okay, perfect. I can stop registration, and that's it. And have a nice weekend, and see you on Monday morning.